Now in the previous lecture, we have learned how can we delete a node in binary search tree. Now in this lecture, we will talk about how can we delete an entire binary search tree. So here, the concept is very simple. If we have implemented a binary tree with a linked list, we just need to delete the root node from here. When we delete the root node, the children of root node becomes eligible for garbage collection. So garbage collector comes and delete these nodes from the memory, and the next node becomes eligible for garbage collection, and it continues like this until we have deleted all nodes from this binary search tree over here. Now in this case of binary search tree, if I set root node to null, in this case the root node is 70, so it's going to be deleted from the memory. So after it's deleting the memory, these left and right children becomes eligible for garbage collection. First it's going to be deleted left child, then it's going to continue to delete right child from the memory. Now with this, we have successfully deleted binary search tree from the memory. Now let's implement a method for deleting entire binary search tree from the memory in practice. Now inside this binary search tree class over here, we are going to create a delete method for deleting binary search tree. So it's going to be like this, delete BST. So it's obvious that it's not going to take any parameters. So in this case, it's going to be like this, the by public void delete BST. So we don't have any parameters. So inside this method, all we have to do, we have to set root node to null. Now after setting it, I'm just going to print out to the console saying that binary search tree deleted successfully. So it's going to be like this, print when so BST has been deleted successfully. Now with this, we have completed our deletion method for deleting entire binary search tree. Now let's call this method in this main class to see that how this is working. So here, instead of level order traversal, I'm just going to call delete BST. Then after that, we can call level order traversals that to see that if this is deleted or not. So if I run our code, you see that first it says that binary search tree has been deleted. Then we have an error over here. So this means that we don't have binary search tree and we are trying to call level order traversal for the binary tree that is missing in the memory. So that's why we have an error over here. So that's why it gives us null exception over here. Now with this, we have completed deletion of binary search tree. Now let's see what's the time and space complexity for this method. Now it's obvious that the time complexity will be O1 because in this case we have only 2 lines of code and both lines take O1 time complexity. Now the space complexity is also O1 because in this case an extra space is not required to perform this operation over here. So that's why space complexity is also O1. Now with this we have come to the end of this lecture, so hopefully everything is clear about deletion of a binary search tree from the memory. So see you in the next lecture.